Hey y'all! Well, today we're going to be talking about the update for my music room that I'm working on diligently with these audio engineers. And while I'm sitting here recording this video, I'm reminded of one of the reasons I'm doing this. My neighbor is right outside with their giant backpack leaf blower. They've been out there for the last 45 minutes. I want a place where I can get away from that and not have to listen to people's lawn equipment all weekend, because it really ruins a music listening experience when you have to have the noise floor in your house raised 10 decibels because somebody's obsessed with manicuring their lawn, which I'm sure some of y'all live in an urban area and you have to deal with. And so that's part of the goal of this room, is to lower the noise floor in the room. And as part of that, one of the reasons that I decided to do this project was after going to Exponent and looking at the cost of like kind of the next level in audio gear from this mid-fi gear that I'm at, you know, with a $10,000 amp and $15,000 speakers, that kind of range. You're starting to spend pretty serious money to get like upgrades from that. And I know there's folks that'll argue that you're not going to hear any difference going from a, you know, $5,000 speaker, or some people say a $500 speaker. But I've heard them. There is a difference, but it becomes diminishing returns. And so I decided that at this point, what my listening experience or my audiophile in the hobby experience, the upgrade is going to be is the room. And there's really no rooms in my current house that are the right dimensions or that could be soundproof to the level that I need to not have to listen to their leaf blowers when I'm listening to music. Or, you know, in my case, part of this is, you know, I want to have a space that if someone wants to buy one of my amplifiers, they've got a nice environment to listen to. And somebody comes over to my house at, you know, 2 o'clock on a Saturday afternoon to listen to one of my amplifiers, and that just happens to be when my neighbor decides to have 3 guys with 2 weed whackers and a leaf blower, and then another guy doing a lawnmower all at the same time. You're not going to be able to hear anything. And so what I do say, you know, we can't do the demo today. You're going to have to come back. You know, that's not going to work either. And so, especially if they've driven from out of town or flown into town, you know, because if somebody's going to spend $5 or $6 grand or more on an amplifier, it wouldn't be out of the question for somebody to fly into Atlanta to listen to it before they buy it. And so, anyway, so I did, as some of you know, I hired a acoustical engineering firm, Adam Sound. I'll put it up here, also put it in the description. They said they're fine with me sharing all of the stuff that they're showing. And so we're going to go over like the room dimensions that they've come up with for my particular thing. We're going to talk about the room layout, or the 2 rooms. There's going to be a workshop area and then a listening room area. And they're 2 different sized rooms, and they're going to be, anyway, we'll go over that. I'll get on my computer in a minute and kind of go over that, show you some wall construction details, what we've decided on for the size of the room. I'm going to run some videos for you showing the heat maps in the room, both the inside of the room and the walls of the room at different frequencies going from 20 to 200 hertz. And that's where the room is the deal. Over 200 hertz, it's room treatment and still the room, but it's speakers and speaker placement, and you can fix a lot of that. But the under 200 hertz is the stuff that's hard to fix. And it's probably why those leaf blowers are so irritating. The ones that they use are those 4-stroke steel ones that have a really low frequency buzz. Like the 2-stroke ones I don't even hear in my house. But those low frequency droning kind of leaf blowers. Like I can't even hear their lawnmower, but that for some reason that frequency of that leaf blower, it's around 100 hertz and it just penetrates walls, windows. This is a concrete block room downstairs and it's almost like you're standing outside. It doesn't block any of it. And so that's what I'm trying to deal with this room. And also to design it in a way that the resonant frequency of the wall itself is down below 50 hertz. And even though, you know, these speakers I'm going to be using legit go down to 20 hertz, there's not a whole lot down there where the wall, you know, the resonance is 30 hertz or thereabouts. It's not going to be near as noticeable as if it would be if it was like at 70 hertz or 100 hertz, which is where a lot of just drywall resonates. And so that's part of the goal with this wall construction, is to get the resonant frequency of the wall below where most music is. And so it's going to make the room a whole lot easier to treat, and you don't have, you know, the walls in the room getting excited and amplifying, working like a passive radiator, which is what's actually going on when the walls start resonating. It's amplifying those frequencies, which is not what you want to be listening to. And so anyway, let me get on my computer and I can show you more about like the dimensions we've come up with, the wall construction, the layout of the floor, how we're likely going to be doing some of the HVAC stuff, although we haven't gotten to the detail of that, and some things that I've taken out of the plans that I was initially going to do, but I've realized that if I did all of this, it would just go way over budget and I would never end up being able to afford to build it. So anyway, let's jump on the computer and let me show you what's going on with our room. Okay, so first we're going to go over the wall construction that we're planning on using for this sound shed. So we're going to be using 2x6 studs on 24-inch centers. And we're originally going to use this Safe and Sound insulation, which is a 3-inch thick batting material. And doing some research, it has a pretty low R value. And so it's really not going to be great for exterior walls, even though the climate in Atlanta isn't extreme, I would say. It still gets pretty hot in the summer, and I want this room to be as energy efficient as possible. And so doing some research, the same company makes a material called comfort bats that are slightly less dense, but they're thicker than the normal Safe and Sound insulation. And they come in 5.5-inch deep bats, which will fit perfectly in these 2x6 stud walls. And so we're going to be using that for the insulation on the wall, and it should give an R21 to R23 depending on which product they end up using, and we'll go over that later when I research that more. But that's going to be plenty of sound and environmental insulation. So the other thing, and let me show you over here in this other corner an example of a reference of what would be considered kind of a normal soundproof wall that someone would use with these ISOMAX clips with a resilient channel kind of a thing. This wall would be 8 7/8 inches thick. It's got a 1/2-inch pine sheathing with, you know, whatever siding that's on the outside. Could be vinyl, could be hardy plank. Yeah, I'm not sure what we're going to end up using, but that's kind of irrelevant to this calculation. And then you have the ISO clip here with the hat channel, and then you have 2 layers of 5/8 sheetrock. And most people would go, wow, that's pretty serious sound deadening. And the STC is 57. But here's the thing that's important. Even with all of this, the resonant frequency of the wall is 56 hertz. So what we're going for here is a higher mass wall trying to lower the resonant frequency down to 30 hertz. And this wall will have a STC rating of 78. So we're going to be using these ISOMAX clips with, I don't know if you'd really call it resilient channel. It's more of a hat channel that fits into these rubber inserts that are made into these clips. And then the first layer is a 1/2-inch cement board like you would use in a shower stall kind of situation. Then green glue. Then we have a 1/2-inch OSB on top of the cement board. And then we have 5/8 sheetrock on top of that. And on the outside of the building, we're going to have this same 1/2-inch cement board, 1/2-inch pine sheathing or, plywood, whatever it's going to be, and then the siding. This is a almost 10-inch thick wall. And again, the resonant frequency is calculated at 30 hertz instead of 56. And the STC is 78 versus 57. A lot more soundproof, a lot lower resonant frequency, which is the thing that I'm more concerned about than getting the STC rating this high. We had initially looked at doing 1/2-inch cement board with no green glue, 1/2-inch OSB, and then 2 layers of sheetrock, and came up with a very similar STC and just slightly lower resonant frequency. I think it was 28 hertz or something like that. And so removing 1 layer of installed material, which I think will substantially lower the cost of assembling this, plus then there's less weight on these clips, so we'll need less of them. And then we're having to use green glue, but I'm okay with that because I kind of like the properties that having the sandwich layer construction creates using that viscous material, sort of viscous material between the layers. The other nice thing I like about this is we have this OSB that stuff can be mounted to, like the panels and that sort of thing. So we can use short screws that just go through the drywall into this OSB to hang the acoustic treatments and pictures and lighting and all that kind of stuff. So it makes really a nice wall. So when we go over here to the interior wall between the listening room and the workshop, very similar construction, except for this time we've got 2 layers of 5/8 drywall on the outside instead of this sandwich construction. Now I may talk to them and see if it makes sense to try like this 1/2-inch cement board and a layer of drywall on top of that, and see if that gets us to a similar STC and resonant frequency that we've got on the other 3 walls. And I'm going to ask them about that and see what they think about that setup, because I don't think that would be a lot more expensive to go with a cement board and then drywall sandwich on the outside of this interior wall. And then for the ceiling, we're going to do a very similar thing where we've got this same 3-layer sandwich that's going to be hanging on these Isomax clips. And then this is going to be the bottom piece of the truss, or if we go with a stick built, it'll be the ceiling joist. And then on top of that, we have the same cement board and pine sheathing, and then it's going to be stuffed with that same comfort bat material that we're using in the walls. And then to get the higher R value that we want for the ceiling, to insulate it from the roof for, to help keep it cool in the summer and that sort of thing, we're going to put some insulation on the top here too. And that's the wall construction we're going to. And you can see, again, here's the STC ratings. It's going to be 70 plus. Should work really well to keep the noise out of this room and to get the resonant frequency low. So let me pull up another drawing here that shows the room dimensions. Actually, let me show you this rock wool comfort bat insulation that I'm planning on using. And down here it has the different ways you could do the wall construction. But we're going to be looking at this product. It says it's available in the US, and you see here it's 5.5 inches thick, and they make it in a 23-inch width for the 24 on center stud spacing we're going to be using, and it's an R value of R21. Now I'm not sure what this R23 is. It's got a different RSI value. It's the same thickness. Got to do a little research and see what the difference is between these two products, this R21 and R23. Probably going to go with this R21. I think it's probably going to be a little denser product, but again, need to do some research on that. But that's what we're going to be using inside the wall for the insulation and to help with the soundproofing. I like the way this stuff is kind of a semi-rigid insulation that fits tight in the wall and helps seal up the studs, and it helps dampen the studs from them resonating. So yeah, I think this is going to work really well. So let me get to another drawing here. So this is a floor plan that I drew up in the SketchUp software, and this is tentatively how the room's going to be arranged. And I'm allowed up to 750 square feet, plus or minus a little bit. And so this fits in with that requirement, and they're measuring the interior square footage, not the outside of the envelope. So these 10-inch thick walls are not going to be part of the calculation for the square footage. So the main listening room is going to be 16 feet wide by 26 feet long, and it's going to have an 11-foot ceiling. And this is tentatively just kind of the way the room's going to be set up. We're going to have speakers about this position in the room. Then the couch or the listening position will be in this area right here, with a nice space between the couch and the back wall to allow whatever sound treatment we're going to put on this back wall to do its job and not be hearing those reflections off the back wall. The door is going to be into the side of the room, like right here, and they want it 3 feet from this corner, and it's a 3-foot wide door. Probably going to be going with a soundproof rated door. I'm still shopping those. Some of them are like crazy expensive, and I'm trying to avoid having to buy like a $6,000 door. And there's some that are more in like the $2,500 range that are still pretty massive doors. but they're not quite as high a STC rating. But I'll explain here in a minute. We're going to be using this workshop area as a buffer between the outside world and this door. If this door was like an exterior door, or it was going to be open to the outside world, probably have to break down and buy a really expensive door. But given that we're going to be separating this room and this room with this door, and then this room's going to have these walls, even though they're going to have windows and stuff, it's still going to knock off a bunch of the decibel level of the outside world, from here to here. So then this door isn't going to be as critical. And you might be thinking, why are you doing this really heavy duty wall here between the two rooms? And it goes back to trying to lower the resonant frequency of these walls. Now, the walls for this workshop area are not going to be like mega soundproofed. They're going to have probably a single layer of drywall on the inside, same kind of sheathing on the outside as this part, so that it's, level across here. This wall might have the exterior without the concrete backer board on it, because again, I don't think this room needs to be as soundproofed or worried about the resonant frequency of these walls, since there's not going to be music playing, or at least trying to get super high quality music in here. We are going to have windows. Haven't decided exactly where I'm going to put them, but this is an approximate location of where I'm thinking about putting the windows. And then I'm going to have a door here with glass in it to let some light in through this door as well. And then in building this room out, I'm going to frame out future window openings in the stud wall, with headers and jack studs and all that stuff, so that in the future, if me or someone else wants to transform this into an accessory dwelling unit, or wants to repurpose it for something else, that holes could be cut through the siding and windows put in, and turn this into like a living room area. Potentially this could be, or a bedroom, and put a bathroom back here or something, that sort of stuff in the future. I'm kind of future-proof the buildings, but for now, this room's not going to have any windows. And again, this is kind of the floor layout that I'm looking at right now, and I think this is plenty of workshop space. Having a 13 by 26 foot room, got this big long wall here. You can put workbenches along here. Potentially, I might put a stud wall here with a door to make this like a woodworking area, and then have this like the electronics workshop, but haven't decided on that yet. We'll see how my budget holds up. So let me show you their drawings for the dimensions of the room and how they wanted this laid out. And so we were originally going to lay the two rooms out like this. And problem with this was going to be that this door going into the listening room was going to be to the outside world. And then it would have required to have a second door into what's they're calling the ADU, or the workshop area. And I decided that moving this here made a lot more sense. Or, well, there's the door, but you know what I'm saying. That putting them making the building like a square thing instead of a long rectangle with two entrances made a whole lot more sense to me. But here are the actual dimensions of the room, and you can see they want 26 by 16, and then 11-foot ceiling. And those are the interior dimensions, with the door 3 feet from the corner. And they did quite a few different renditions of this. We tried a smaller room, and it was interesting when we were looking at doing a smaller room. They said that the only way they could get the simulations to even start to look good was to have the ceiling angled from front to back. And it was basically going from like an 8-foot ceiling to a 10-foot ceiling in the smaller room. And they actually said that the ceiling being angled made more difference than any of the wall construction stuff. And so that was pretty interesting, conversation we had about that and the extra cost of the construction and trying to figure out how to do the roof and all that stuff with the angled ceiling. And then when they went to a slightly larger room, I think originally it was like 14 by 20. And when they went to this 16 by 26, they said that the angled ceiling made a whole lot less impact on the room. And that it actually improved the size of the sweet spot for listening going to a flat ceiling versus the angled one. And while the angled ceiling made like this one point in the room better, it made the sweet spot where you could listen a lot smaller. And so I felt it was a perfectly fine compromise to give up a little bit of perfection in this one spot to have a bigger sweet spot where we could have 4 or 5 people sit in this area and be able to enjoy the music, maybe even 2 rows of seating, instead of having just like one seat that was just slightly better. So the idea here is the speakers are going to be a little over 3 feet from this front wall, and they'd be like this distance apart. They're saying about 10 feet apart. So speakers would be like 3 feet from each wall. Obviously, this can get moved around as we tune the room once we get it built. But this is kind of what we're shooting for. And then being 15 feet from the front wall, which gives you about 10 feet behind where you're sitting of open space for whatever weird resonant stuff to happen back here. And should give a really nice place to sit and listen to music with plenty of room between the listener and the speakers. And that's why we're doing this mainly, is to get away from near field listening and try to open up the sound that we're getting out of the system. So that's what the room's going to look like. And yeah, that kind of covers what we've done so far. Now, they did send me a initial sound treatment, which I kind of freaked out when they sent me this. Let me find this. So this was their rendering with a max effort room treatment. And this is not what I'm going to be doing. They've got, as you can see, almost every square inch of the walls, the back wall. They've got stacked bass traps in the corners. They've got this array of stuff here in the front. This is like the side wall. They've got a mixture of, looks like, diffusion and absorption on the side wall. And then this is, I believe, the front wall. And they've got some diffusers. Then they've got just 3 stacked bass traps with stuff. Yeah. This was the other side wall. Got diffusion, looks like, and then some absorption with all this stuff that's in the back. And then this is, I believe, the back wall. And again, bass traps, panels, 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 panels. And then here's the ceiling. And you can see they've got just, what is that? 16 panels in the ceiling, and they sent the BOM for it, and this was $22,000 worth of room treatment. And yeah, that's not happening. And I'm not even sure that's what I would want in this room. And so they're doing a multi-tier treatment plan for the room. And they're going to start off with, like, here's kind of the minimum that we would recommend. And that's what I'm going to start with and just see how the room sounds. I'm really concerned about over-treating the room. This looks like the room being over-treated. And, you know, yeah. Let me know in the comments what you think about this. But, yeah, I'm not, at least right now, I'm not even considering putting over $20,000 worth of room treatment in this room. In addition to all the special construction we've done, I'm just, yeah. I mean, maybe this would sound really great. Not sure. But this just seems excessive to me. And again, I'm going to see what they come back with on like a multi-phase, pathway to doing the room treatment. But I mean, I'm sure this would kill every resonant frequency that entered this room, but I'm not sure that's what I want going on. I'm not building an anechoic chamber. And besides that, just the cost is just way beyond what I'm willing to spend, at least at this point. So anyway, that kind of wraps up where I'm at with the room right now. And I've got my architect working on drawing the preliminary drawings. I've talked to the city, the planning department. They're all fine with this. They basically are going to consider this a shed. And while it's, a she shed or whatever you want to call it, that's a step above a storage shed for zoning purposes, that's what this is going to be considered, evaluated as, and inspected as. And so I'm not going to have to meet any of the really restrictive stuff that's going to be required for doing, some other kind of construction if it was like a habitable space. And then the other thing is, and they're still drawing it like this, but that's okay. The other thing in the electrical is I'm planning on, let me pull up this other. I'm planning on putting the fuse box in this area right here, maybe in this wall. So it's a shorter pathway. And then I'm thinking about doing the electrical outlets in the floor, so we don't have to penetrate the walls, and put, an outlet on the floor on each side of kind of where we're guessing the seating would be, to put phone chargers and all that kind of stuff. And then back here in the back of the room, have some outlets in the floor to power up the amplifiers. Maybe have 3 in this area, have one kind of here, one there, and then one back here closer to the wall. And then if I did do the monoblock amplifier next to the speaker kind of a thing, there'd be a power outlet for that. We'll figure that out when I get into that. Probably going to be running just standard 20 amp outlets. I mean, I know people run like 8 gauge wire and stuff like that. I'm thinking just whatever the standard gauge wire is for a 20 amp service should be fine. And have dedicated circuits for the sound equipment. And anyway, got to figure out the electrical, but that's kind of my thought right now. And then obviously I'm going to put some outlets along this wall here in the workshop, and all around here for plugging in different things and benches, and figure out how I'm going to lay all that out. But definitely going to have a lot of electrical outlets in this room so that you know, we can deal with hooking up different power equipment and power tools and all that kind of stuff. So anyway, I think it's a good place to kind of wrap up this video. So as you can see, got a lot of design work going into this room, and I really think this is going to turn out nice. One of the things, again, like I was saying earlier, when I was looking at what kind of the next level in this hobby would be to have better sound, it was going to be a lot of money, and I'm not sure it would have been audible in the room that I have to put my gear in. And I see people just waxing poetic about, oh, this cable brought this dark background and all that kind of stuff, when at best it's probably lowering the noise floor of their system a couple of dBs. I mean, that's like a stretch that it's doing that. Maybe a half a dB. And what I'm talking about doing is lowering the noise floor 15 to 20 dBs from what it is now in my house. Without, airplanes flying over, cars driving, lawnmowers, just where I'm living in the normal traffic patterns and stuff. And I have noticed that my music sounds so much better listening at like 2 o'clock in the morning, and the noise floor's like 5 dBs lower at that time of the night than it is in the afternoon. And if it sounds that much better, I mean, there may be something else going on, but I really think it's the noise floor is improving the sound that much. And if I can have that lower noise floor all the time and even lower, that I think that's going to make the music in that room sound exponentially better. And so, hey, we're going to find out. And then you'll find out maybe from my mistake that, hey, that didn't really do anything. But watching what Ron at New Record Day and some other folks, Danny's built a room and Jay's built a room, they're all talking about how much better their music sounds when they're in this space. And part of it is that the noise floor is lower, that there is absolutely something to that. And the money this building is going to cost me, plus I'm able to move all my building, construction stuff out into this new workshop, that it's going to be cheaper than a pair of really high-end speakers would cost. And so, and I'm not talking about like Wilson Audio $500,000 ones. And so I think this is going to be a nice investment, and I think it's going to be a fun project, and I hope y'all are going to enjoy going along for the ride as I build it. So if you're enjoying this channel, please subscribe to the channel. Please like the video. Comment below if you think this is cool stuff, or if you're boring. Hopefully you're enjoying it. And subscribe. You'll see updates, and follow along with this build series. I think this is going to be a fun project. So until the next video, have a nice day.